G'day, Lockie here. Today I wanted to share something I'm actually really excited and passionate about in the Kubernetes community, and this is called Service Broker. Now this work has been done in the SIG Service Broker SIG, and there are a bunch of people from Deus that are now at Microsoft that have been working on this for a long time, and I've had the privilege of seeing this actually adapt throughout the years. But what I wanted to start with before we get into what Service Broker is really a little bit of background about why Service Broker is needed. It's something that I like to call the post-it workflow. One of my colleagues at work coined that term. So the post-it workflow is I'm an app developer deploying applications on Kubernetes, and often I have dependencies on external services such as databases, caches, things like that. Now in the post-it workflow, I need a postgres database. What I would do is I'd go and see Daisy, the DBA, and say I need a Postgres instance. She would provision one for me and then pass the credentials to me on a post-it, and I would go and enter them in as a Kubernetes secret. Now, Service Breaker tries to make that workflow automated. So it's about taking off-cluster services and presenting them inside the Kubernetes API. So that flow would look like me asking the service broker for a Postgres instance, it delivering it and laying down those credentials inside. Now, I see a bunch of benefits, and apologies if I'm not doing this justice for the folks in the SIGs that are working on this, is automation of that process and better utilization of resources, because what most folks are doing today is saying, well, I need a Mongo, I need a Postgres, and they're actually rolling their own for each microservice rather than hosting a database in an existing Postgres instance that's under the the SLA or the DBA team internally. So I wanted to create a very short video of the work that's being done. It's absolutely fantastic, and I wanted to couple it with the Open Service Broker for Azure to give you really tangible automation of that whole flow that I just mentioned. So I'm going to put everything in the description. If you like the video, please give it a thumbs up. Otherwise, you should be able to follow along here. I'm going to pop over to the terminal right now, and let me just bump the font. So what I actually have here is a Kubernetes cluster. Now, I've provisioned this Kubernetes cluster with ACS Engine. It's a 186 cluster, and I've actually, inside that repo, it says what you need to do to provision it with ACS Engine, but essentially it comes down to you enabling aggregated APIs, which is a feature in 1.7 and above. I actually have a video on that, but this is about delegating pieces of the API path to another API server so that you can implement new types of resources in Kubernetes without them being CRDs. So enough about that. These videos are not about deep technical content, it's about showing you some value, so I kind of just want to get this up and running. But basically all you need is Helm and aggregated APIs enabled. So I have Helm on here. Now first I'm just going to do a Helm install of the service catalog repo, and it looks like I actually do not have, I didn't purge that last release. So Helm, because I just did this demo before, let me just get rid of this, purge, little Helm fun there. Okay, now what this is going to do is create that API server for the aggregated API. So this is about creating some new resource types that are going to be managed by the service broker. And this work, you can follow along. I will post the links, but it's all installable with Helm. What I'm expecting here is a namespace called catalog. I'm expecting an API server with an etcd, I believe, and a controller manager. So while that's happening, what we will then skip to after this is we will install a broker. Now, what is a broker, you may ask? It's simply an open service broker API, which comes out of the Cloud Foundry team. So it's something that conforms to this open service broker API and delivers anything that you want, any piece of automation. It just has to abide by that API. So you can see here that Helm has exited here. Let's wait until catalog. We'll wait till these both come up. Okay, we have an API server, 2 of 2, and this probably is in crash loop back off because it tried to run before the API server was running. Okay, and now what I would expect here is if it's registered, it goes and registers itself with the Kubernetes API server. API versions, that we actually have a service catalog API version now, which was not there before. Okay, so we're in a good position here. I'm going to install the OSBA, so the Azure Open Service Broker for Azure. So what we're going to do here is deliver a bunch of Azure services without leaving the Kubernetes API. I'm going to show you how that works. I think we've called it OSBA. I'm going to need to do a helm delete OSBA and do a purge before I do an install. And the documentation's there, but basically I've created a service principal for access to the Azure APIs, and I'm just feeding them in as set commands. So subscription IDs, tenant IDs, and this is just required so that this set of services can actually talk to Azure as an account that I've authorized, so they can provision resources on my behalf. Now that's going to go ahead and install. What we should then have access to is a catalog. So this Azure broker delivers a catalog of things that you can install. This, and I'm probably butchering the terminology there, of services. And we'll take a look at what that means in a minute. So kubectl get pods, OSBA. So once this is actually up and running, it's almost there. Okay, so once that's up and running, I want to talk about another tool. So you can interface with all these resources using kubectl, but one of our team members has actually gone and created, actually two of our team members, apologies there, have gone and written this svcat binary that can be installed as a kubectl plugin. So I've actually installed that, and I'll give you the details of how to do that. But I can do a plugin, if I could type plugin svcat, and that'll actually pass you through to svcat. And we can do a get, and we could do instances. So don't have any instances. Let's have a look at brokers. Okay, so it's still coming up, this OSBA broker. Classes. Right, so we've got these classes. This is the different classes of service that we provide. So you can see here Redis, storage, ACI, and I mentioned postgres DB, so we'll actually go with that. But we can provision all these resources without leaving the Kubernetes API. So let me also take a look at, we had plans. So as a user, I can come along, and I like to think of this like PVs to PVCs, and I can put a claim, a PVC, a persistent volume claim, that will be delivered by the PV provider. I can put an instance, which is essentially a claim, to create that service. So if we go and have a look, specifically looking for Azure Postgres DB, so we have a basic 50 and a basic 100. So 50 DTUs. So basically, I can say I want an Azure Postgres QLDB, and I want it basic. So we have different sizes. Again, think of it like storage classes, PVs, PVCs. So as a user, I can say I need that basic 50 Postgres QLDB, please. Now this, if I was not using this, I could do get service brokers. Is it instances, classes? So this is actually querying those class. I don't know what it is. Okay, service instances. So we can actually go and query these because they are proper resources delivered by that aggregated API. But what I like to do here is to use svcat, because as you can see, I can't remember all the commands off the top of my head right now. So we can go back and have a look if our broker is okay. it should come good in a minute or so. But in the meantime, let's pop over to the demo that's actually part of this Upstream repo. And what it's going to do is the following will provision a PostgreSQL on Azure. So if I have this repo checked out, and it looks like it's in the contrib Kubernetes examples, contrib Kubernetes examples. So I'm doing an instance. So in here I'm actually saying, here's a service instance. I'm giving it a name and a namespace. I'm looking for this external name. This is what we saw actually in the plans. And a few other parameters to provision, so firewalls and some extensions. And then I will issue a binding against that name, that instance ref. Again, very similar to PVs and PVCs. So I'm going to go ahead and create this instance. I should be able to do a get instance. That's in provisioning state right now. And I can actually see that service instance there via the proper resource, so you can actually see what's happening under the hood here. It's in provisioning. Resource group is going to be demo, so it's going to live in my Azure account. So we should actually see here eventually that this thing should provision a PostgreSQL server. Now this operation may take 5 to 10 minutes, so I'm actually going to we're back. You can see that this instance is now in status ready. Let's go pop over to our portal here. You can see that I have a Postgres instance under my subscription and that it is up and running. Now the last piece of this puzzle here is to actually create a binding, so to make a claim on that instance. Okay, so we're going to do that. Now what that should yield is a secret. And here it is. It was created 3 seconds ago. Get. Don't worry, I will delete this, but here it is. So here's all the data I would need to go to automate that whole post-it workflow, which is fantastic. So, and if I simply go back and remove the binding, delete, have a look at the secret, it's now gone, and I can create, we can remove the instance as well. And what that should then do is actually remove it from my portal. It should disappear fairly shortly. Now, this is super cool. Thanks for listening. Hopefully I didn't confuse you too much and actually showed you the value prop of Service Broker. And I just want to take a moment to thank everybody who's worked on Service Broker and made it what it is today. There's countless hours, but I'm really excited to see how this goes and how people start to use it. So thanks for joining. Cheers.